anytime you're given two terms, a square term and a constant, or anything which is two terms, you always want to ask yourself right away, is there a GCF? In this case, I'm looking at the one on the left. What's the GCF of 12x squared minus 3? 3. The one on the left. That's, unless you went like this, then it's that. All right. So you have a 4x squared minus 1. Does that 3 have anything to do with the problem anymore? No. So in this case here, don't worry about it. Now I've got two terms in my parentheses. Is 4x squared a perfect square? Is 1 a perfect square? Is that a subtraction symbol? That means this is a difference of squares. So this becomes 2x minus 1, 2x plus 1. Your zeros are at plus or minus 1. Okay. If you go the long way with that too, it works, but just pain. Why bother? Trust yourself. What times what's negative 4? You have to get 0. Oh. Same deal here. GCF is 5. You have an x squared minus 4. Is that a perfect square? Is 4 a perfect square? Is that a subtraction symbol? Yeah. So it's plus 2 minus 2. Okay. That's what a lot of people are messing up. It's just that simple, straightforward. Don't overthink it. Okay. The other ones were fine. Aside from maybe you just got lost in a sign here or there. Nothing too nutty on either one. So you guys were doing just fine on those. So I wasn't too concerned. One thing that was concerned is that I tried to get too much in yesterday. What we're going to do via this quiz is it's going to be next Thursday. I know that's after the SAT stuff, but what's going to happen is that way we can put in the section 5354 stuff, which is basically the same thing that we're working on right now, and just add that into the start of it tomorrow, finish it Friday, work on it again on Tuesday after the weekend, and then we'll be ready to do all that. So just basically adding this like a section and a half to the quiz as opposed to normal. It's not a big deal. I was looking back at notes and stuff like that from what I've done in years past. I was trying to sneak that in before the 3-day weekend, but I was looking at what we did last year, and it was basically the same pacing on it, so it's not the end of the world to add those things here. So you don't have to worry about it for tomorrow, because I know we got a lot of word problem stuff to talk about today. Okay? So with that, let's go back over where we were at yesterday we did this one in class, the baseball one. I think we left off right around the idea here of projectile being launched. Okay? Now, when we're doing these types of problems, I need you guys to start to think about, what does this mean? I don't know if you realize that every one of these projectile problems had that minus 16t squared. Do you know what that stands for? Gravity. Gravity, yeah. It stands for gravity. Gravity pulls things down. Did you know that? Now you do. So, now, let's think of this. What do you think that 80t is representing? The force against gravity, which means it's your initial velocity. How hard you're throwing something up, because it's positive. That's where that comes from. It's all physics stuff. If you're not in physics, you probably may not have known that, or you haven't gotten to forces and stuff yet, so eventually you will know that. A lot of stuff that we do in here has roots that go into physics, so you can apply it pretty easily. Yes.
Can you put that on my head?
I could, but I like my job. Once again, I like my job. But what if I hit Beanie? His mom will beat me up. All right, anyway, so we're here, and when you're reading this one, this is a standard form equation. It's just written backwards. The reason why they put it backwards is because they don't like to put the negative up front. You still have a negative a squared, which means your parabola is going to be down like a frown, which means you're going to have some sort of a maximum. So when you start to visualize what in the world this is going to look like, we know we have some parabola that's going to look like that. There's some maximum value, but there is one dead set value you know for certain. Where does it cross the y-axis? At 96. Okay. You know that somewhere along the line it's going to cross the the y-axis at 96. So that means that it's on its way up or it's on its way down at this value. My guess is that it's on its way up. The only reason why I'm saying that is because we have a velocity that's being shot out at some initial height. This is the starting height of the curve. So that tells me that this is probably doing this. And it looks something along like that. What it looks like in the graph, I don't know exactly, but just from that C value, I get the idea of what it's doing. Does that kind of make a little bit of sense if I kind of visualize it up front? Okay. Now, the height is your Y. Your time in seconds is your X. Okay. Now, the question was, it's launched vertically upward at the top of a 96-foot tall tower at time equaling 0. Well, that's exactly what we have here. So it's launched. Whee! How long does it take to hit the ground? That's basically what you're looking for. Now, when you're thinking about when it hits the ground, that means that this value here, your Y value becomes what? 0. Very good. So in this case, we're trying to figure out the x-intercept so that Y is 0. So, thank you for not hitting her in the head. What you're looking at here is you're throwing this in the calculator, and we're going to try and mess around with our window. And I know that it takes a little bit of time to get accustomed to messing with the windows. There is no dead set, always going to work. There's a lot of trial and error. So let me open up my calculator. I don't care. This is our graph, wasn't it? Yeah. 96, 80, yeah, okay. So I throw this in there, and what I'm going to start guessing around with my window is I really don't care what's happening to negative values of x. We can easily change this. Let's say it's at -5. We'll make our x maximum 20. Our y minimum -20, our y max at 200. The reason why we're sitting there is because I'm trying to figure out how high up did that get thrown when it's starting already at almost 100 feet. Did it get thrown upward more than 100 feet higher than that? We're just searching for the graph. Okay. I know yesterday she was talking about changing your scale. If you change your scale, you'll just see less tick marks on the y value. It doesn't really affect anything. That's why that YSCL is at 20. We did that. We got to this problem yesterday in the third hour, so that's why we have that here. So if I hit my graph button, I got something like this. It's the number 2 on that sheet. My window, I'm at -5 for x, 20 for positive. I'm -20 for y, 200 for y, but my y scale, that YSCL, is at 20. The only reason that I did that is because it's just showing less tick marks here. It just looks a little bit cleaner. That's the only reason. You don't have to do that. All right. Now it looks like it peaks below 200 from what it appears for what I'm looking at here. Everybody okay with that? Yeah. All right. So now what we're doing here is we're trying to figure out. See if I can. Oh, I don't want to do that all the way. I'm trying to minimize this a little bit. So at this point, our graph looks like this. Now, there's an option on the graphing calculator to find a 0, because you're trying to figure out how long did it take to hit the ground. Well, it hits the ground when your height is 0, so that means that's your x-intercept, because your height is your y value. Okay? So when you go to look for when we start searching for it, in the calculator, what we do is we hit second calculate. I say second calculate because the calculate is the blue value. Once you hit the second, you're going to that upper screen levels of the options on the keys. I hit second calculate, and one of the options is 0. Okay. So select option 2, or just enter, move down and hit enter. Either one is fine. And now you are on your graph. Right now, my cursor, I don't see it. My cursor says I am at x equaling 7.5 and y is equaling negative 204, which means I'm way down there somewhere. I need to find it. So I need to move to the left because I'm past it. So I'm going to move back so I can see my graph. See how my x values are coming up? So I think we did this, it's been a while, but when it's asking you these questions in terms of the boundaries for where it's going to search, it wants you to be the left of the 0, where it crosses the axis, and it wants you to be the right of the 0. So normally what I do is I move as close as I can to the x-axis before it switches from positive to negative. Ooh, see how it switches from 1.6 to negative 20? So my left boundary, I'm going to put it there, and I'm going to hit enter. My right boundary, I'm going to go past it, because now I'm negative. My y value went from positive to negative. Somewhere in between there, it crossed 0. You okay with that? So I hit enter again. Now it says, after it says that, it says guess. I don't care. Nobody cares. I don't know why it says guess. No one's ever told me. And I'm never going to call TI to ask them. So, blue. There's my 0. It happened at 6 seconds. Okay? Not always is it that clean of a number, though. Okay? Not always will it be that clean of a number, but it does work. Yes, ma'am. So I get 0. I get 0. Just move over. And then you go to the left and right of as you cross over. Okay. All right. So far, so good? Yeah. Yes, sir. Guys. You want to see at least the vertex and where it's crossing zeros. You want to see that because at the tails you really don't care. Yes, ma'am. Yes. So what she's saying is 1e to the negative 11. That means 0. Okay? You'll see that. You'll get a little rounding errors here and there, and it just means it's 0.
Can you please show us how to do this here?
Yeah. Second, calculate. Okay. All right. Well, I'll redo it on mine too here. So I'll go back to my graph. I'm going to hit second, calculate, option number 2. And then what I'm looking for is on the graph, you have your cursor right now. I want to get to this 0 because it's positive. I don't want the negative 0 because we can't go back in time. We're not in a DeLorean doing 88 miles an hour. Okay? So, thank you. So, notice my y value here is positive. If I move to the right one, it becomes negative. So, that means it jumped from positive to negative. So, somewhere in this value, it crossed 0. So I go back to where it's positive. That's going to be my left boundary. I hit enter. Now it's asking where do I want to place my right boundary. So I go to where it becomes negative. I hit enter. The next option is always going to be guess, whether we're finding zeros, maximums, minimums, intersections. Just hit enter one more time. And now it comes up with mine at 6. Okay, no problem. All right. Now, did that also ask us for the maximum height?
Yeah.
Okay. So when you're trying to find the maximum height on this one, we use a different calculation. So we know that this height has to be a maximum. So you're doing basically the exact same thing. Second, calculate, and now we're going to select option number 4 because it's a maximum. If you chose number 3, it won't work because it'll say not a maximum, and you'll go on from there. So it forces you to know that that is a maximum. And right now my cursor is down near where my 0 was. So what I need to do now is move it to the left where the maximum appears to occur. So I'm to the left of where the maximum is. I hit enter. I go to the right of where it is. So I'm just looking where it starts to come back down and hit enter. It doesn't have to be super specific, one right after another for these values. the calculator will do all of the work for you. So what it's doing right now, it's searching through all the possible values of x between these two boundaries that we are doing, and doing all these calculations within milliseconds to figure out what value gives you the biggest y. Okay? Hit enter. And the maximum here is when x is 2.5. So at 2.5 seconds, it's at 196, was it feet on this one?
Yeah, we didn't go the exact.
What did you get?
I got 2.44441.
Okay.
With 2.4999.
Okay. And then what's your y value?
196.
Yeah. It's all within that realm. And that's the thing when it comes to this, these sets of problems. I know that there is variance within your window versus my window, and it does different calculations. I know that there'll be some variance within the value. So then if you got 6 and 412, I know you screwed something up. But if you're within a couple hundredths, you're fine. Because it's usually going to be that close with these numbers. Okay? John, what do you got? I had a question. Glad we had this conversation. Yes. Ben? Alright. Let's try another one. Why don't you guys take a second? The next one was the negative 16t squared 48t and a 160. Gives the height of an object thrown from a building 160 feet high with an initial speed of 48 feet per second, where t is measured in seconds. Find the amount of time for the object to hit the ground and find the maximum height of said object. Sir? If you could, that's great. If you didn't figure it out because the calculator was not holding it accountable. So we barely got to start most of this. Right? So try this one here, throw it in the calculator, play around with the window, and see if you can figure it out. Besides playing video games.
Yeah.
Let's download it.
Oh, God.
Before I change the window. Oh, I guess the window.
Yeah,
Well, check your window because that one had it at your C value is different. So one of the things that I would notice on this one I know that my C value is at 160. So I know then that my Y maximum should change. Maybe make it to 300. All I'm doing is just trying to guess. Because right now our Y maximum is at 200, and it might get that high up there, it might not, I don't know. But all I'm doing is just kind of guessing and checking. Oh, I accidentally did it to negative. All right, so it worked. Okay. All I did there was I'm just messing around trying to figure out. Once again, I'm going to search for a 0. Do you guys ever use a table? No. Object throw. I'm doing the number 3. Okay. Now, when you guys look at this graph, doesn't it look like it's going at 1, 2, 3, 4, at 5? It looks like it's kind of crossing at 5. Now, in our tables, if you hit second table, if it happens to be an integer value, If it happens to be an integer value, you should get 0 for y somewhere. In this case, we got 0 for y at 5. So sometimes if it appears as though it's crossing at a clean number, does it take 2 seconds, if that, to check your table? Yeah, check your table. If not, then you'll know that if it jumps between positive and negative between two numbers, then you know it's somewhere in between there. Then you would know where to start fishing for it when you're doing your left boundaries and your right boundaries. So here, I can use my table quicker and say, oh, it's after 5 seconds, it hits the ground. Okay? But now, in terms of the maximum, though, notice in the table, somewhere between 1 and 2, since between 1 and 2, they're both at 192. So it has to go between, it has to be up higher between that, because you'll see that these are your symmetric twins. -2 and 5, -1 and 4, 0 and 3, 1 and 2. It means there's some value in between there that is the axis of symmetry. So, gee, I wonder what the axis of symmetry is at. So do our left boundary again?
Oh, it's at 1.5.
Yeah. I mean, you could have done all that just by looking at the table and figured it out, but it's no big deal. That's what the calculator's for. This is the type of things I'd let you use the calculator for. So here it's giving me my, that's just dumb luck. It's giving me my maximum at 1.5 seconds, it reaches 196. Those are heavy. I'm going to write it on. Keep going, see how fast goes, see how soon it moves down. Hit enter. Hit enter one more time. It's that easy. The window? So you can see it. Not every graph. No, that way you can see the graph. It just so happens these last two graphs were visible in the same window. That's just dumb. It doesn't always happen. All right, let's switch over to the other packet. I'm on page 5. With sports. I'm on page 5 here, ladies and gentlemen, talking about the curvature of the football field, soccer field, why it's pitched like that. Why do you think they're pitched like that? Rain runoff. Why do you think roads are pitched? Rain runs off. Truer words have never been spoken. So, when we read through this problem, it's asking us, it says, football field appears to be flat, but it's not. It's actually shaped like a parabola, so rainwater drawn off either side. Cross-section of the field with synthetic turf can be modeled by Blanc. Where X and Y are measured in feet. What's the field's width? What's the maximum height of the field's surface? Now, when you're looking at this form, what form is that? It's vertex form, isn't it? So if this is vertex form, this is your y equals a x minus h plus k. Now, just knowing that little bit tells you a lot. Where's your vertex? 80 and 1.5. So my vertex is at 80, comma 1.5. Which means at the center of the football field, how much taller is it than it is on the ends? 1.5. Okay? It also means that the x value the halfway point of the football field is 80 feet. How wide is the football field? 160. It's 160 feet across because from here to here is 80, which means from here to here has to be 80 more feet. So that means the total distance of the field is 160 feet. For this model, it is. Okay, for this model, it's, what is that, 33 and a half, 33 to 30 yards? I don't know how wide the ball field is.
Oh, it's one way. Oh.
Yeah. Now, did I even need my calculator for that? No. The idea here is that you understood that it was vertex form. What does vertex form afford you? And it tells you where the vertex is. The vertex also happens to be the x-coordinate of the axis of symmetry. So if you start at 0 on one side, you got to go all the way to the other. You're halfway there is the axis of symmetry. Well, if the axis of symmetry is at 80, you started at 0, you have to go another 80 feet to get to the end. That's what that comes from. Thank you. Thank you very much. How's everyone here? Oh, this is one of my favorites. It's page 7. First of all, the one above it, where it says traffic engineering, I forgot to import a picture for that, so go ahead and cross it off. The traffic engineering, just cross that one off. Jackie Joyner-Kersee won the women's heptathlon in '92 Olympics in Barcelona, Spain. Her throw at the shot put, one of the 7 events in the heptathlon, can be modeled by blah, where x is the shot put's horizontal distance traveled in feet and y is corresponding height in feet. How long was her throw? So, what does the 5.5 represent?
Where she like how tall she is,
Where she held it.
She threw it.
So as she was going, it's down. He'd actually Nelson, she shot puts, right? Get,
Your Murphy deal.
She's not going to want to come in here, but she does do it. My sister. I'm going to get my sister. That's not fun.
Blue blinds.
She's not going to come over the wall. She's not going to Everyone's like,
she's not. So I know this, but you know how to shot put. I don't. Do the spin around thing and shot put it. Don't get anybody in the way.
I thought she was gonna hit the computer.
not very happy with me now.
Oh, this is great. Anyway, so yeah, you're looking. If you can't have fun at your job, why not, right? So the idea here is, again, is that 5.5 foot represents the height of where it started. Notice how Ella threw it, most like Jackie Joyner-Kersee. It went up, and then it went down. Somewhere along the line, it hit the ground, didn't it? It did. So again, if you're starting to think about this, where did it start on the graph? 5.5. And then it went and hit the ground. Couldn't you just fill out the calculator, find some zeros, change your window? Yeah, that's the idea.
Well, amen. Oh, I'm saying, let's go. That's a little.
Oh,
I'm gonna do one more like this, and I'm gonna let you guys go on some problems here. Yeah, because you can throw stuff. Page 11. A department store sells 20 portable stereos per week at $80. The manager believes that for each decrease in $5 in price, 6 more stereos will be purchased. Okay? So this is missing a whole lot. Now, what I was asking, when I went to put this in here, I think when I put the second one, I covered up somehow. The question here was going to be, at what price would they sell the most? Okay, it's that idea of that sales cost figure that we did yesterday. So here, again, you have units being sold at a specific price. This forces it into a quadratic via intercept form. All right? So what I want you to do, whenever you see these things for increased price, decreased sales, or decreased price, increased sales, always think of it as it's always going to go intercept form. You have two figures then. You've got units, and then you've got money. That's usually how these always work themselves through. So in the units portion, I know that I sell 20 of them. At what price do I sell that? At 80. So think about in terms of foiling. If I sold 20 of them at $80, my revenue would be $1,600, I believe. So that's what you're talking about, your total revenue. Now, profit, we're not doing anything like that because there's no constraints here. Okay. Now, it also says for each $5 increase in price. So is that $5 going to go with the 80 or with the 20? It's going to go with the 80. Now, that's an increase. Oh, I'm sorry. I thought it said increase. Sorry. So the decrease of 5. Now, does it tell you how many times you're decreasing it? That's where the X comes into play. Remember, this value of X is the number of times something's occurring. What?
Wait, on mine it says 16.
What? Excuse me? Which one?
he's on a different.
It's okay. And then it says 6 more will be sold. So your units, so you wind up with this. When you have this style, I want you guys to always do intercept form and find your axis of symmetry. Get your zeros. This is forcing you into zeros. So you solve for your zeros. So if I do that, oops. If I set both these equal to 0, what's 80 divided by 5?
14. No, 15, no, 13. No, 16.
Which is it? Which of those?
17. 16.
There's only a machine that would allow you to do this correctly.
Ours are 30. It's 18. No, it's not. It's 17.
One of my zeros is at 16. The other one would be at negative 10 over 3. Okay. Set it equal to 0. So negative 20 divided by 6, usually negative 10 thirds. So bless you. Now, that's kind of a messy one to figure out in terms of the values because it's not clean. Now, the moment that I see that happening, that it's not clean, I'm going to immediately go back to my calculator. Is there any reason for me to FOIL that out?
No.
No. Your calculator will accept it in terms of any format you put it in there. If I put it in there with parentheses, it'll still do the same thing. So let me clear out my graph. I do parentheses. What was it? 20 plus 6x, 80 minus 5x. And if I go to graph this, we know that our revenue We're gonna change our window, don't we? Okay. So we knew that if I multiply that, the 20 and the 80, we're at 1600. So I know that I probably should change my my range maybe to like a 2000 for my y value. What's that? That's okay. We're getting there.
Okay, that's it. One.
I did 6,000. Okay.
I put on a 0.
Well, you're just trying to get an idea of where it's occurring. So now we're trying to figure out the x and y values at the max. So we got to figure out how many times we need to increase or decrease to get the maximum revenue. So we hit second, calculate maximum again. Yeah.
I don't know what it is.
It's all messed up. Should go now. Type sign. It says plus sign. Yeah. So go to my left there. Go to the right. Nope, I didn't hit it. So if my x value is at 6 1/3, my y value is 2803. Now this is a weird one because of the third here. It's kind of difficult to increase things by, they're instead of increasing it X amount of times, they're increasing it by decreasing by 6 1/3. So they're decreasing it by the $30 because it's $5 decrease per, and then a third of the $5. So it gets kind of weird. Now, I wanted to show this one because it doesn't work out as cleanly as most of the other ones do, because sometimes you can go back and use your calculator to figure that out. So the number of times they would have to decrease to get the maximum is at, so our value was at 6 1/3, and it was 2803 1/3. Okay. Now remember, this just represents the number of times it's getting discounted. How many times you take off $5? All right. So your selling price would have been $80 subtract 5 times 6.33. That's what you would sell it at to get the most revenue. So if I did that, 80 minus 5 times 6.33. I sold it for $48.35. So even though there's a weird decimal thrown in there, the selling price could still work out clean-ish. Okay? Just wanted to show you guys some of those weird ones, just in case. All right. Now, with the stuff that we've done, you should have no problems to do. Let's see, on the front page, we did the number 1. The quilting problem number 90 should be good. Page 2, oh, there's the quilting problem. Page 2, the quilting and the mural should be all right. 98 should be good. We did 99. 100 is good. That's the one we just, kind of like what we just did. 101 is good, the Big Bertha. The car one is easy. The physiology one, we'll talk about that one tomorrow. The rat one is easy. Yeah, most of these should be pretty easy to do. I would do your best to get as many of those done as possible. Like I said, if you can't figure out the construction one on 91, that's fine. If you can't figure out the mural on 97, that's okay. It's a little weird, but for the most part, this should be pretty straightforward with the setups and stuff. All right? Decent?
No, yes.